Good evening, Bhavishya.
Good evening, ma'am.
Good evening. Yeah, we stopped here when we were doing understanding quadrilaterals. Yeah, match this. Yeah, we'll continue with understanding quadrilaterals. The answers are not ready for the test which you have written. I'll prepare the answers and then we'll discuss it. All right?
Okay, ma'am.
Yeah. Yeah. Now tell me, Bhavishya. You can do it like this, you know. Now look at this simple closed curve. Is this a simple closed curve?
No, ma'am.
Okay, so no, not this. Then is this one a simple closed curve?
No, ma'am.
Is this a simple closed curve?
Yes, ma'am.
Is this a simple closed curve?
No, ma'am.
Is it a closed curve? Is this one a closed curve?
No, ma'am. Yes, ma'am. It is a closed curve, ma'am, but it is not simple closed curve.
Why is it not simple?
Ma'am, because it is intersecting the line.
It's crossing over itself. Correct. So this one goes with this. Now take the next one. A closed curve that is not simple. So choose the figure which is a closed curve but not simple. Is this closed?
No, ma'am.
Is the first one closed?
No, ma'am.
Is the second one closed?
No, ma'am.
No. Third is already matched. Is the fourth one closed?
Yes, ma'am.
And it's not simple, right?
Yes, ma'am.
Yeah. Then simple curve that is not closed. A simple curve that's not closed. Sorry?
Ma'am, first one, ma'am.
Even this is not closed, no? The second one is also not closed.
Ma'am, but it is not a simple curve, ma'am.
Yeah, but it's not a simple curve. But it's not a simple curve. Oh, you seem to be very confident, Bhavishya. I like that. So the second one is a closed curve. Okay, sorry. The second one, is it a closed curve? No, it's not
No,
closed. Yeah, second one is not. So both the first and second are not closed. First one is not closed. Second one is also not closed. But the second one is also not a simple curve.
Yes, ma'am.
Because it's intersecting itself, yeah. But this one is simple curve. It should be a simple curve. That means it should not intersect itself. And that is not closed. It should not be closed also. So the first one, correct?
Yes, ma'am.
So obviously this one, D goes with the second one. Not a simple curve. Because it's crossing over itself. All right, very good. Have you matched them like this?
Ma'am, I have written the answers like the straightly, ma'am.
Against, okay. Against the figure, you have written the correct answer. Correct?
Yes, ma'am.
Very good. All right. Okay, so you can see a closed curve here. You can see a closed curve here. And this region is called the shaded region is called the interior of the closed curve. And you can see the closed curve here. This region is called the exterior of the closed curve. Now, see here. If I draw a triangle, okay, this is the interior of the triangle or the interior of the closed curve. Okay, now this is the exterior of the closed curve. This is the exterior of the closed curve. You understand?
Yes, ma'am.
Okay. Yeah, make a quickly draw this in your book.
Ma'am.
Yeah.
Ma'am, I'm Swati, ma'am. I have joined it, ma'am.
Yeah, good evening, Swati. Good evening.
Good evening, ma'am.
Yeah.
Ma'am, and I have also shared the test paper that you have sent on Wednesday.
Yeah, I saw. Yes. I didn't see, meaning I didn't check, but you had sent some images. I got it.
Yes, ma'am.
Okay, good. So you've also completed all the tests, right? Up to date?
Yes, ma'am. I have completed and it's sent to you, ma'am.
Very good. Okay, fine. Yeah. We just started. We discussed this one. This is where we stopped in understanding quadrilaterals. We started the chapter understanding quadrilaterals, and this is where we had stopped. And then we had taken up a couple of tests. Now we are resuming understanding quadrilaterals. We just discussed this one, and now we are doing this.
Yes, ma'am. Ma'am, since my school has completed this topic, I'm clear with this, ma'am.
Very good. Okay. Yeah, make a note of finished. Make a note of this one, children.
Yes, ma'am.
Yeah. Done? Yeah, write on this. Yeah. So what is a polygon? A simple closed curve made up of only line segments is called a polygon. A polygon is a simple closed curve. So now you know the meaning of the term simple closed curve, line segments. So a simple closed curve made up of only line segments is called a polygon. And each straight line segment in a polygon is called its side. Now see this? If I draw a figure like this. Now this one is a closed figure. This one is a closed figure. It's a simple closed figure because it's not intersecting itself anywhere. The line segments are not crossing over themselves anywhere. And it's made up of only line segments. It's simple because the figure doesn't intersect itself anywhere. It's simple, it's closed, and it's made up of only line segments. So this is called a polygon. And this polygon has 5 sides. So polygon meaning it's a simple curve, simple closed curve made up of line segments. All right. Yeah, make a note of this. Done?
No, ma'am.
Okay.
Done, ma'am.
All right. Okay. Yeah, you don't have to. If you can draw the figure, but just or if you feel it's in the textbook and you can refer it from there, just go through this. I'll ask you some questions based on this. Yeah. So what is a 8-sided polygon called?
Octagon, ma'am.
9-sided polygon?
Nonagon, ma'am.
Nonagon. 5 sides?
Pentagon, ma'am.
Pentagon, ma'am.
Pentagon. 7 sides?
Heptagon, ma'am.
Heptagon, no?
Yes, ma'am.
Yes, ma'am. Heptagon.
Or heptagon. It's also called a septagon. Heptagon or a SEP, septagon.
Yes, ma'am.
All right, fine. So you can see here curves that are polygons. These curves are polygons. These curves are not polygons. Now, why are these curves not polygons? Why are they not polygons? Because this one is this simple? Because what is a polygon? It's a
Simple closed.
simple. It should be a simple closed curve made up of line segments. Made up of line segments. So you should check for these 3 things. It should be simple, it should be closed, it should be made up of line segments. There are 3 things: simple, closed, and line segments. Is this simple? No, because it's intersecting itself. It's intersecting itself. Is it closed? No, it's not closed because the starting point and the ending point, they're not the same. So it's not closed. The start point is not equal to the end point. It's not the same as the end point. So it's not closed. But it's made up of line segments. So it's made up of line segments, but it's not closed. See, because if you start like this and you end here. If you start here, you're ending it here. So the start and the end point, they're not the same. So it's not closed. And it's not simple because it's intersecting itself. So it's not simple. It's only made up of line segments. So this is not a polygon. This one is not a polygon. Now this one, is it closed? Is it closed? Supposing you start from here. If you start from here, you go like this, like this, like this. You come back to the starting point. You come back to the starting point. So it is closed. It's closed because you come back to the starting point. Is it simple?
No, ma'am.
No, ma'am.
No, because it's crossing over itself. But it's made up of line segments. So this is closed. It's made up of line segments. But it's not simple. It's not simple because it's crossing over itself. So this is not a polygon. What about this?
Ma'am, it is not a closed.
It's not closed.
But it's open.
Yeah, it's not closed. Because if you start here, this is the ending point. The start point and the end point, they're not the same. So it's not closed. It is made up of line segments. It's not closed, but it's not closed. It's not closed, but it's made up of line segments and it's simple, but it's not closed. So it's not a polygon. So these are some curves that are not polygons and these are curves that are polygons. All right.
Yes, ma'am.
Okay. All right. Next. Yeah.
Ma'am, can
Have you
you show
done
me
this?
the first slide?
Sorry. Yeah.
Okay, ma'am.
Yeah. Yeah, you don't have to draw these diagrams. You don't have to draw these diagrams. Just make a note of the definition of a diagonal and the formula to find the number of diagonals in a polygon.
Ma'am, those non-consecutive vertices can also be non-adjacent vertices. Ma'am.
Yeah, non-adjacent vertices. Yes.
Yes, ma'am.
Done, children?
Done, ma'am.
Done, ma'am.
Yeah. Yeah, make a note of this.
I'm along with the figures.
Yeah, you can make a rough sketch. Yeah.
Yes, ma'am.
Yeah. I'll just come back. Please make a note of this. Done, children?
No, ma'am.
Okay.
Done, ma'am.
Yeah. So if it's a convex polygon, all the interior angles will be less than 180 degrees. See here, all these interior angles, the measure of all these interior angles will be less than 180 degrees. In a convex polygon, the measure of each interior angle will be less than 180 degrees. The measure of each interior angle will be less than 180 degrees. Okay, like this here also. In a concave polygon, at least one interior angle will measure more than 180 degrees. That means it will be a reflex angle. It will be a reflex angle. will be more than 180 but less than 360. In a concave polygon, at least one interior angle will be a reflex angle, that is, will measure more than 180 degrees. In a convex polygon, all the interior angles, the measures of all the interior angles will be less than 180. All the angles will be less than 180 degrees. In a concave polygon, at least one interior angle will be a reflex angle. That means at least one angle will be more than 180 degrees. So see here in this figure, this angle is the reflex angle. See, these are the interior angles. 1, 2, 3, 4. These are the interior angles of the polygon. This one is a quadrilateral. It has 4 sides. 1, 2, 3, 4 sides. It's a quadrilateral. It's a concave quadrilateral. It's a concave quadrilateral. These are the 4 angles of the quadrilateral. 1, 2, 3, 4. These are the 4 angles. And you can see this angle is a reflex angle. It's a reflex angle. Now this one has how many sides? 1, 2, 3, 4, 5, 6, 7. So this one is a septagon. Septagon or a heptagon. Okay, there are 7 sides. So it's a heptagon. Now see this angle, the measure of this angle. This angle is a reflex angle. Its measure will be more than 180 degrees. So it is a concave heptagon. Concave heptagon. 1, 2, 3, 4, 5. Pentagon. Concave pentagon. Because this interior angle, not this angle, don't see the angle outside. This one is an exterior angle. This is an exterior angle, not this angle. Interior angle inside the figure. The measure of at least one interior angle will be a reflex angle. So see inside the figure here. This is a reflex angle. Similarly here, this is a reflex angle. All right.
Yes, ma'am.
Yeah. Yeah, make a note of this. I'll just tell you what regular and irregular means. In a polygon is said to be a regular polygon if all the sides and angles are equal. Okay, if all the sides are equal and all the angles are equal, it's a regular polygon. Otherwise, it's an irregular polygon. That means if it's not a regular polygon, it's called an irregular polygon. A regular polygon is a polygon in which all the sides are equal and all the interior angles are equal. If it is not a regular polygon, it's called an irregular polygon. Now, an equilateral triangle. This one is an equilateral triangle. An equilateral triangle is a regular polygon because all the 3 sides are equal and all the 3 angles measure 60 degrees. So 3 sides are equal, 3 angles are equal. So an equilateral triangle is a regular polygon. A square. A square is a regular polygon. It's a regular quadrilateral. An example of a regular quadrilateral is a square because in a square, all the sides are equal and all the angles are also equal. Each angle is equal to 90 degrees. Now this one is a regular pentagon. This one is a regular pentagon because it's marked, all the sides are equal. The sides are marked equal, so all sides are equal and all angles are equal. It's marked here. It's marked all angles are equal. So it's a regular pentagon. This one, 1, 2, 3, 4, 5, 6. It's a regular hexagon. It's a regular hexagon because it's marked that all the sides are equal. See, all the sides are marked equal and all the angles are also marked equal. See, you can see the double lines here. All angles are also equal since it's marked. Sides and angles are equal. So it's a regular hexagon. So an equilateral triangle. Equilateral triangle is a regular polygon or it's a regular triangle. A regular quadrilateral is a square because all sides are equal, all angles are equal. If it is not regular, it's irregular. Right on, children? Done, children?
No, ma'am.
Okay. Now, in a rhombus, all the sides are equal, but all the angles are not equal. So it's an irregular polygon. In a rhombus, all the sides are equal, but all the angles are not equal. So it's an irregular polygon. But in a rectangle, all angles are equal, 90 degrees, but only opposite sides are equal. All the sides are not equal. In a rectangle, all the angles are equal, but only opposite sides are equal. All the sides are not equal. So it's irregular. Let me know if you're finished, children.
Done, ma'am.
All right.
Done, ma'am.
Good. Yeah. Now, now we'll be mostly concentrating on convex polygons. That is polygons like this. Okay, we'll mostly be concentrating on convex polygons like this, not such polygons. Okay. Now, in a convex polygon of n sides, the sum of all the exterior angles is equal to 360 degrees. Whatever polygon it is, whether it's a triangle, quadrilateral, see here, polygon, convex polygon, not triangle or not quadrilateral or pentagon, convex polygon, whatever polygon it is, in a convex polygon of n sides, so that it can be 3 sides, 4 sides, 5 sides, 6 sides, any number of sides. In a convex polygon of n sides, the sum of all the exterior angles is 360 degrees. So see here, now if you take a triangle, okay, it has 3 interior angles and 3 exterior angles. So when you produce the side, see, this is the interior angle, this is the exterior angle. When you produce this side, this is the interior angle, this is the exterior angle. When you produce this side, this is the interior angle, this is the exterior angle. We know that angle 1 plus angle 2 plus angle 3 is equal to
180 degree, ma'am.
180 degrees. We know that angle 1 plus angle 2 plus angle 3 is equal to 180 degrees because the sum of the 3 angles in a triangle is equal to 180 degrees. Angle 4 plus angle 5 plus angle 6 is equal to 360 degrees. Angle 4 plus 5 plus 6 is equal to 360 degrees. Now take a quadrilateral, okay? Angle 1, angle 2, angle 3, angle 4. The sum of the 4 angles, in a quadrilateral is equal to 360 degrees. The sum of the 4 angles in a quadrilateral, that is the angle sum property in a quadrilateral, is 360 degrees. When you produce this side, interior angle, this is the exterior angle, 5. Anyways, you can produce it. You can produce it like this also. Interior angle, this is the exterior angle, 6. You can produce it like this. Interior angle. So this is the exterior angle, 7. Interior angle, exterior angle, 8. The exterior angles, angle 5 plus angle 6 plus angle 7 plus angle 8 will be equal to 360 degrees. In any polygon. So even if you take a, polygon with 6 sides, 1, 2, 3, 4, 5, 1 minute. Even if it's a hexagon, whatever. Make it regular. Yeah. Okay, there's a hexagon. You can see this is one side, 2, 3, 4, 5, 6. It's a hexagon, but it's very clear that it's not a regular hexagon because the sides are not equal. The sides are not equal. Now see here, this is the interior angle. Produce it, this is the exterior angle. Interior angle, produce it, this is the exterior angle. Interior angle, produce this side, exterior angle. Interior angle, produce this side, exterior angle. Interior, produce exterior. Okay, so now this is an exterior angle 1, exterior angle 2, exterior angle 3, exterior angle 4, exterior angle 5, and 6. If the polygon has 6 interior angles, it will have 6 exterior angles. If a polygon has 6 interior angles, it will have 6 exterior angles. Now the sum of all these 6 exterior angles is equal to 360 degrees. So that means in a convex polygon of n sides, any number of sides, the sum of all the exterior angles is always equal to 360 degrees. Now, what about the sum of all the interior angles? That will differ. It differs as the number of sides increase, their sum will also increase. As the number of sides increase, the sum of the interior angles will also increase. Now, how do you find the sum of all the interior angles? If you want to make a note of something, not needed, but if you just want to make a note, I'll just wait for 2 minutes.
Done, mom.
Yeah. Yeah. So in a convex, see, we are talking only about convex polygons. So in a convex polygon of n sides, the sum of all the exterior angles is always 360 degrees. Now, if the polygon has 3 interior angles, it will have 3 exterior angles. If it has 4 interior angles, it will have 4 exterior angles. The sum of the interior angles will increase with the increase in the number of sides. Now, a triangle has 3 sides. The sum of all the angles is 180 degrees. 4 sides, 360 degrees. Quadrilateral, 4 sides. The sum of all the interior angles is 360 degrees. Pentagon, 5 sides. The sum of all the interior angles is 540 degrees. Like this, it will keep increasing. But the sum of all the exterior angles is always 360. Now, how do you find the sum of all the interior angles? We know it's not the same. It differs for different polygons. Then how do you find the sum of all the interior angles of a polygon? Now, if you take, say, a hexagon, 6 sides. Now take any point on the hexagon. Say you take this point. Divide from this point, divide the hexagon into triangles. So like this one triangle. From this is the second triangle. And like this, 3, and 4. So you choose any, excuse me, you choose any one vertex. You choose any one vertex, and from there you divide the hexagon into triangles. So you can divide the hexagon into 4 triangles. See, that means if you put the 4 triangles together, you get the hexagon. So what is the sum here? 180 degrees. Here 180. Here 180. Here 180. So the sum of all the interior angles of a hexagon is 720 degrees, because 180 into 4 is 720. Now take a pentagon. Take a pentagon. It need not be a regular pentagon. Any pentagon, okay? Take any vertex. Choose any vertex. Supposing you choose this vertex. Divide the pentagon into triangles. So you join like this, you get one triangle. When you join like this, 2, 3. There are 3 triangles. The pentagon can be divided into 3 triangles. The sum of all the angles in a triangle is 180 degrees. So 180, 180, 180. So 180 into 3, 540 degrees. Quadrilateral. Quadrilateral. You can divide it into 2 triangles. 180, 180, 360 degrees. So like this, you can divide all the figures, all the polygons into some number of triangles. Now, what do we observe? What do we observe? Now the quadrilateral has 4 sides. The quadrilateral has 4 sides. Okay, so quadrilateral has 4 sides, and it's divided into 2 triangles. A pentagon has 5 sides, and it's divided into 3 triangles. Oh no, this is not pentagon, sorry. This is a hexagon. Sorry. This is a pentagon. A pentagon has 5 sides, and it's divided into 3 triangles. This one has 6 sides, and it's divided into 4 triangles. So what we can see is the number of triangles formed is 2 less than the number of sides. See here, if n is 4, that is the number of sides is 4. Then the number of triangles is 4 minus 2, 2. If n is 5, see here, n is 5. N is 5, the number of sides is 5. Then the number of triangles formed is 5 minus 2, 3. 3 triangles. If n is 6, that is the number of sides is 6. The number of triangles formed is 6 minus 2, 4 triangles. See here, 7, or I'll take 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay, choose any vertex. Supposing you choose this vertex. So 1 triangle, 2, okay, so how many triangles? 1, 2, 3, 4, 5, 6. Number of sides, 8. Number of triangles formed, 8 minus 2, 6 triangles. So the number of triangles formed is always 2 less than the number of sides. So if the number of sides is n, the number of triangles formed is n minus 2. So many triangles are formed into 180 degrees. Why into 180? Because the sum of all the angles in one triangle is 180 degrees. So in n minus 2 triangles will be n minus 2 into 180. The sum of all the angles in one triangle is 180 degrees. Then in n minus 2 triangles will be n minus 2 into 180. Is it clear, children?
Yes, ma'am.
Yes, ma'am.
Okay. So I'll just tell you once again. 1, 2, 3, 4, 5, 6, 7, 8. Choose any vertex. 1, 2, 3, 4. See here, a triangle can be formed here, like this. This is 5, this is 6 triangle. So number of sides, 8. Number of triangles formed, 8 minus 2, 6. 1 triangle, 180 degrees. 6 triangles, 6 into 180 degrees. So the sum of all the interior angles, the sum of all the interior angles of a convex polygon with n sides is n minus 2 into 180. N minus 2 into 180. Or see, this is the formula. It ends here. It ends here. That's all. This is the formula. It ends here. But in some schools, you know, we learn it like this: 2n minus 4 into 90, or 2n minus 4 right angles. So I'll just explain that also. See, this is the formula. If you want to remember this, that's all. It ends here. Okay, then how can it be 2n minus 4 into 90? So you can write 180 degrees as 2 into 90. You can write 180 degrees as 2 into 90. And multiply the 2 inside now. 2 into n, 2n. 2 into 2, 4. So 2n minus 4 into 90. Or 2n minus 4 right angles. Do you understand?
Yes, ma'am.
So you can just remember this: n minus 2 into 180 degrees, or 2n minus 4 into 90. Anything. These are the two formulae. This one or this one. You can remember this, or you can say 2n minus 4 into 90. Now, so this is, now remember this carefully. So if it's a convex polygon with n side, the sum of all the exterior angles is always 360 degrees. The sum of all the interior angles is equal to n minus 2, number of sides minus 2. So many triangles are formed, into 180, or 2n minus 4 into 90. So this is one part. Now next, in a convex regular polygon, that means regular meaning all the sides are equal, all the angles are also equal. That means whatever is the total value, the total interior angles divided by n will be the value of each interior angle. Why? Because it's regular. All the angles are equal. All the interior angles will be equal. All the exterior angles also will be equal. So they are sharing it equally. So in a convex regular polygon, meaning all the sides are equal, all the angles are equal of n sides. Sum of all the exterior angles is 360. That we know. Each exterior angle is equal to 360 by n degrees. Why don't we say 360 by n here? Here because the angles, all the exterior angles are not equal. The sum is 360, but the exterior angles are not shared equally because it's not regular. If it's regular, the angles, the exterior and interior angles will be shared equally. So each exterior angle is equal to each exterior angle is equal to 360 by n. All right. I'll come to this later. We'll come to this later. Now, the sum of all the interior angles is n minus 2 into 180. Or if your teacher has told you 2n minus 4 into 90, anything. So each interior angle will be n minus 2 into 180 by n, or 2n minus 4 into 90 by n. Yes or no?
Yes, ma'am.
Yes, ma'am.
Yeah. But what do we know? That the interior angle plus exterior angle is always equal to 180 degrees. Because see, if you take a quadrilateral, when you produce this is an interior angle, this is the exterior angle. The sum is always 180 because linear pair. Now this is the interior angle, produce it. This is the exterior angle. Interior angle plus exterior angle is on a straight line, linear pair. It's 180. Each interior angle plus each exterior angle is always 180. So you can say that each interior angle is equal to 180 minus each exterior angle. Yes or no?
Yes, ma'am.
Or
Yes,
each
ma'am.
exterior angle, yeah, each exterior angle is equal to 180 minus each interior angle. Each interior angle. All right. That's what I've written here. Each exterior angle is 180 minus each interior angle. Each interior angle will be equal to 180 minus each exterior angle. Yeah, write on this, children. Very important. Write on this. I'll just come back. Please make a note of this. Done, Swati and Bhavishya?
Yes, ma'am. Done, ma'am.
Okay, yeah.
Done, ma'am.
All right. So the in a convex polygon with n sides, that is 3, 4, 5, 6, 7, 8. So n sides. Okay, the sum of all the exterior angles. Sum of all the exterior angles is always 360 degrees. And if it is a regular polygon, then each exterior angle, the sum of all the angles is 360 degrees. All exterior angles 360 degrees. If it is a regular polygon, then each exterior angle will be 360 by n. Because see, why by n is because if a polygon has 3 sides, it will have 3 angles also. If a polygon has 8 sides, it will have 8 angles. So if it has 8 sides, 8 angles. So it will be 360 divided by 8. All the 8 angles will share 360 degrees equally. So the sum of all the interior angles, the sum of all the interior angles in a convex polygon of n sides is n minus 2 into 180. Or you can say 2n minus 4 into 90. And if it's a regular polygon, then each interior angle will be by n. By n. Always remember that each interior angle plus each exterior angle plus each exterior angle is equal to 180 degrees. They always form a linear pair. If you take a pair of interior and exterior angles, the sum will always be 180 because they form a linear pair. Is this clear, children?
Yes, ma'am.
All right. Yeah, this I've already explained earlier, children. Now you can just take a screenshot. When I started quadrilaterals, I remember I explained all this. So you can practice, you can just take a picture and, write it down again to recall. Take a picture.
Took, ma'am.
Took, ma'am.
Yeah. I had written it. That time I did not have the presentation. So I wrote it and I explained it to you. Now it's ready. You can take a picture. Done?
Took, ma'am.
Took,
Okay.
ma'am.
Yeah.
Took, ma'am.
Yeah.
Took, ma'am.
Yeah.
Yes, ma'am. Took.
Yeah.
Done, ma'am.
Yeah.
Done, ma'am.
All right.
Done, ma'am.
Yeah. All right. So that's about the introduction to this chapter. Let's start working. Problems. Yeah. Yes. Do the third and the fifth one. 3 and Swati will say the answer for the third one and Bhavishya for the fifth one.
Yes, ma'am.
Both of you have learned it in school. Even Bhavishya has learned this chapter in school. So Yes, Swati, what's the answer for the third one? I just want the final answer.
Yes, ma'am. Ma'am, the answer is 360 divided by 7, and that is 51.4.
I
And it
told you
goes
I
on.
want only the answer and you're telling me the steps. Okay, no problem. Fine. Yeah. What's the answer?
Ma'am,
What's the final answer?
and the measure is 51.42, and it goes on, ma'am.
51.42 degrees. All right, very good. Yes, Bhavishya, have you finished the fifth one?
No, ma'am.
Okay.
Ma'am, 24.
24, is it? Yeah, how did you get 24?
Ma'am, by 360 degree by n, we will write 360 by 15, ma'am. So by cancelling, I have got 24, ma'am.
Correct. Because it's a regular polygon of 15 sides. Very good. Yeah. This is how you should present your answer. So we know that each exterior angle of a regular polygon is 360 by n. 360 by n. So Swati's answer is this one. 360 by 7, which is 51, 3 by 7, or you can leave it as a decimal, like what you said. And this is Bhavishya's answer, 360 by 15, which is 24 degrees. All right?
Yes, ma'am.
Yeah. Yeah. This is the next question. Is it possible to have a regular polygon, each of whose exterior angles is 50 degrees? Is it possible to have a regular polygon, each of whose exterior angles is 50 degrees? So what is it? Each exterior, just write what is given. What is given? Each exterior angle is equal to 50 degrees. Now, how do you compute each exterior angle? 360 by n degrees. 360 by n is equal to 50 degrees. So that means 360 by n is equal to 50. So when you work this, you get n is equal to 360 by 5. 360 by 50, sorry. And n is equal to 5, 7, the 35.2. N is equal to 7.2 or 7, 1 by 5, whatever. Now, number of sides cannot be, a fraction like this or a decimal like 7.2 or 7, 1 by 5. So it is not possible to have a regular polygon, each of whose exterior angles is 50 degrees. See the answer here? Each exterior angle is 50 degrees. I've just written what is given. Each exterior angle is equal to 50 degrees. I've just written what is given. Then how do you find each exterior angle? 360 by n. 360 by n. So 360 by n is equal to 50 degrees. Now cross multiply. N into 50 is equal to 360. N is equal to 360 by 50. N is equal to 7, 1 by 5, which is not a natural number. Because number of sides has to be like 4, 5, 6, 7, n, no? Therefore, it is not possible to have a regular polygon, each of whose exterior angles is 50 degrees. Right on, children? Let me know once you've finished writing. Done this one, children?
Done, ma'am.
Bhavishya, Swati?
Done,
No,
ma'am.
I don't know who answered. Both of you done?
Yes, ma'am.
Yes,
Yeah.
ma'am. Yes, ma'am.
All right. Find the measure of each interior angle. Find the measure of each interior angle of a regular polygon having 10 sides, 15 sides. What's the formula, children? What is the formula? How? Okay.
Ma'am,
One
n
minute,
minus
children.
2 into 180 degree.
Yeah. What is n minus 2 into 180? It is the sum of all the interior angles of a polygon. Now, this is a regular polygon. So, how do you find each interior angle? N minus 2 into 180
N
by?
minus 2 into 180. N,
By?
ma'am.
By
N,
n.
ma'am.
By n. Very good. Yes, children. Please write. Any formula you can use, children. You can use n minus 2 into 180 or 2n minus 4 into 90 by n. Anything is fine. In school, what have you learned? N minus 2 into 180 or 2n minus 4 into 90? Which one?
Ma'am, n minus 2 into 180, ma'am.
Swati?
Same, ma'am.
Oh, then I'll correct this slide. Okay, fine. Normally, okay, fine. I'll also work that way also. Finished?
No, ma'am.
Okay. No hurry. Yeah.
Done, ma'am.
Yeah.
1 minute, ma'am.
Yeah.
Done.
Yeah. Is it possible to have a regular polygon, each of whose interior angles is 100 degrees? Okay. So we know that, each interior angle, because the formula for each, interior angle is n minus 2 into 180 by n. and each exterior angle is 360 by n. So like this is simpler, right? Each interior angle is n minus 2 into 180 by n. Each exterior angle is 360 by n. So what we'll do, from what is given, interior angle is given, right? We'll first use this formula. Each interior angle plus each exterior angle is equal to 180 degrees. Okay, each interior angle is 100 degrees. 100 plus each exterior angle is equal to 180. So each exterior angle is equal to 180 minus 100, 80 degrees. But how do you find each exterior angle? 360 by n. 360 by n is equal to 80. So you will get n is equal to 360 by 80. When you do this, you will get a fraction. So it's not possible. Okay, I've worked it like this itself. Fine. Okay, then I'll work this clearly for you. You can do it like this also. See here. Okay, let me show you this. So you can work it both the ways, children. So see here, each interior angle of a regular polygon is given to be 100. How do you find each interior angle? 2n minus 4 into 90 by n. You can write n minus 2 into 180 by n. You can write 180 n minus 2 into 180 by n here is equal to 100. Is equal to 100. Okay. So when you cross multiply, you get 100n, and this 90 will come for division. This 90 will come for division. So 2n minus 4 is equal to 1 minute. Since you've learned n minus 2 into 180, let me work that itself for you. Let's do it together, children. Let's do it together. What will come here in the step?
n minus 2 into 180 by n, ma'am.
N minus 2 into 180 by n is equal to 100. Then next step.
Ma'am, n minus
180 n minus 360 degrees is equal to 100n, correct?
Yes, ma'am.
Then 180 n minus 100n is equal to 360, correct?
Yes, ma'am.
80 n is equal to 360. N is equal to 360 by 80. N is equal to 9 by 2. 9 by 2 is not a natural number. So it's not possible to have a regular polygon, each of whose interior angles is 100 degrees. You can also work it like this. Each interior angle plus each exterior angle is equal to 180 degrees. So 100 plus each exterior angle is equal to 180 degrees. Each exterior angle is equal to 180 minus 100, 80 degrees. So how do you find each exterior angle? 360 by n is equal to 80. So n into 80 is equal to 360. N is equal to 360 by 80, and then the regular thing. N is equal to 9 by 2, which is not a natural number, no. You're right on, children? Please work both the methods.
Ma'am, if they are same in the test, can we solve it using any of the formula?
Any method is fine. Both are correct.
Yes, ma'am.
Yeah. Done, children?
Can you show me the before slide?
Yeah, sure. Yeah.
Done, ma'am.
Yeah. Both of you? Swati?
Yes, ma'am. Done. Yes, ma'am.
Okay. So the question is, see, I put these questions, next to one another. So here we had to find if it is possible to have a regular polygon, each of whose exterior angles is 50 degrees. So what should you write? You should just write what is given. Each exterior angle is equal to 50 degrees. And then exterior angle formula, 360 by n is equal to 50. Here also you can use that interior angle formula. See here. Here also you can write, tell me, just to make me happy that you've understood. What can you also do here?
Ma'am, each interior angle plus each
Yeah,
exterior
each interior angle plus each
exterior angle is equal to 180 degree, ma'am.
yeah is equal to 180 degrees. Then each interior angle
Equals
plus
180 minus each exterior
Ma'am,
angle.
plus
Ma'am.
50 degree is equal to 180 degree.
correct. So each
Interior angle is equal to 180 minus 50, ma'am.
130. Now what's the formula to find each interior angle?
360 by n, ma'am.
Interior angle.
Ma'am, n minus 2 into 180 by 2.
Correct, by n is equal to 130. Then multiply 180 into n, 180 n minus 360 is equal to cross multiply 130 n. So you'll get 180 n minus 130 n is equal to 360. 50 n is equal to 360. N is equal to 360 by 50. N is equal to
36 by 5, ma'am.
36.
7 by 5. Yeah, 36 by 5. N is equal to 7 by 5. The same thing, not a natural number, so it's not possible. So whether each exterior angle is given or each interior angle is given, you can use any method. All right?
Yes, ma'am.
Yes, ma'am.
Okay. Yeah, this is easy. What is the sum of all the interior angles of a regular pentagon? Tell me, how do you do this? What's the formula to find the sum of all the interior angles?
N minus 2 into
180, ma'am.
Into 180. And if it's a non-again, what is the value of n?
9, ma'am.
9, ma'am.
9 minus 2 into 180. So this you can do. I'll just leave this one. Okay. Yeah. What is the number of diagonals in a heptagon? What's the formula to find the number of diagonals?
N minus 3.
n into n minus 3 by 2.
By 2, ma'am.
N into n minus 3 by 2. Okay. Now there are many diagonals. Now if you take a, if you take a, to divide it into triangles, we have only 1, 2, 3. This is to divide it into triangles, 1, 2, 3, 4 triangles. But you have more diagonals. See, you can draw diagonals like this, like this, like this. And from this vertex, you can draw like this vertex like this. Diagonals, there are many diagonals. But when we divide it into triangles, when we divide the polygon into triangles, for that it is like this. See here, 1, 2, 3, 4. 1, 2, 3, 4 triangles. But that doesn't mean that we have only these diagonals. There are many more diagonals. This is to divide the polygon into triangles to find the angle sum property, or to find the sum of all the angles in the polygon. You're getting the difference?
Yes, ma'am.
Yes, ma'am.
Yeah. So this polygon has many more diagonals. So how many diagonals in a heptagon? N into n minus 3 by 2. So 7 into heptagon, 7 into 7 minus 3 by 2. So 7 into 4 by 2. So 14 diagonals it has. Yeah.
Ma'am, can you show me the fifth question, ma'am?
Oh, yeah.
And should we have to write the 6th question?
Sixth question, no? This one?
Yes, ma'am.
No, it's simple. So 1 second. No, you don't have to work, children. It's simple, no? Just the formula and substituting in.
Yes, ma'am.
Yeah. N into n minus 3 by 2 will give you the number of diagonals the polygon has. Okay. Find the number of sides of a regular polygon whose each exterior angle measures 40 degrees. So what is given? Let's write what's given. Each exterior angle is equal to 40. Okay, is equal to 40 degrees. So that means 360 by n is equal to 40, correct?
Yes, ma'am.
Each exterior angle is 40. That means 360 by n is 40. So we should work this and find the value of n. Yeah. Take a picture, children. Okay, so here what I've done is I've written the formula like this. Okay. Here what I've done is, see here, each exterior angle is equal to 360 by n, right? So that means n is equal to, if you cross multiply, what you get? Each exterior angle into n is equal to 360, correct? Correct?
Yes, ma'am.
So
Yes,
what is
ma'am.
n then? 360 by each exterior angle. 360 by each exterior angle is n. Yes or no?
Yes, ma'am.
Yeah, I have written this formula. N is equal to 360 degrees by each exterior angle. I have written number of sides is equal to 360 by each exterior angle. You can also do it like this, children. Not that you should do it like this. You can also do it like this, like I started working, no? What did I write? Each exterior angle is equal to 40. That means 360 by n is equal to 40. Cross multiply 40 n is equal to 360. N is equal to 360 by 40, which is 9. You can do it like this also. Anyways. All right.
Yes, ma'am.
Yeah. Yeah. Find the value of x in the figure. Find the value of x in the figure. Yeah. We'll do this one and wind up the session for today. What is the sum of all the exterior angles of a quadrilateral? This one is a quadrilateral. You can see that
360 degrees.
Yeah, ABCD is a quadrilateral and 90 degrees is an exterior angles. All these angles marked on exterior angle. See, this is the interior angle. See, this is the exterior angle. This is the interior angle. This is the exterior angle. Interior angle, exterior angle, interior angle, exterior angle. So all these angles given are exterior angles, the 4 exterior angles. We know that the sum of all the exterior angles in a polygon is equal to 360 degrees. The sum of all the exterior angles in a polygon is equal to 360 degrees. 90 plus 50 plus 115 plus x is equal to 360. So solve and find the value of x. Yeah, children. Can you take a picture and do it later?
Yes, ma'am.
Yeah.
Yes, ma'am, took picture.
Okay, I have just one more to go in this file, so let me finish it. Now find the angle measure x in the given figure. Find the angle measure x in the given figure. What do you see? It is ABCDE is a pentagon, and it's a regular pentagon because all the sides are marked equal. ABCDE is a pentagon, 5 sides. It's a pentagon, and it's a regular pentagon because you can see the sides are marked equal. All the sides are equal. So how will you find x? Do this. First, find the sum of, okay, since it's time, children. First, what should you find? You should find the sum of all the interior angles of the pentagon. What's the formula?
N minus 2 into 180, ma'am.
So 5 minus 2 into 180, 3 into 180, 540 degrees.
540.
The sum of all the angles is 540. So each angle will be 540 by
5, ma'am.
5.
5, ma'am.
Yeah. Yes, children. Or you can use this formula straight away. N minus 2 into 180 by n. Each interior angle is equal to, you can use this, children. You write this one. I'll also correct the slide by the next class. You can write n minus 2 into 180 by n. N minus 2 into 180 by n. Yeah. All right.
Yes, ma'am.
Yes,
So
ma'am.
each interior angle will be n minus 2 into 180 by n. Each interior angle. Sum of all the interior angles is n minus 2 into 180. Each interior angle will be n minus 2 into 180 by n. Yeah. All right, children.
Yes, ma'am.
Okay. All right, Bhavishya and Swati, that's it for today's session. Thank you. Good night.
Thank you, ma'am.
Thank you. Good
Thank
night.
you, ma'am.
Thank you.